Hello everyone. Today we are going to work on an example which will be an application of modular arithmetic. Now as you recall, modular arithmetic helps us solve problems with situations that go in a cyclical fashion, that move in a cyclical fashion. Examples of cyclical order would be the days of the week, where we have Sunday, let's say the week starts from Sunday, and then we go through Monday, Tuesday, Wednesday, all the way up to Saturday, and then comes Sunday all over again. All right, we get back Sunday and then we move again through the days of the week. So that's an example of a cyclical order. Likewise, the months of the year, January, February, March, April, all the way through December, and then after December comes January all over again. The seasons, right? The seasons starting from spring, summer, autumn, and then back winter, and then back to spring again. That's cyclical. Now, the cycle has a length. Every cycle has a length. So, for example, for the days of the week, the length of the cycle, that means how far do we go before we repeat the cycle? And that would be, in this case, for the days of the week, that would be the number of days in the week, correct? So 1, 2, 3, 4, 5, 6, 7. So the length of this cycle is 7. As for the months of the year, the length of the cycle there would be 12. January through December, we have 12 months, so the length of the cycle is 12. For the seasons, the length of the cycle is 4. And it's important to know the length of the cycle, because when we have to answer questions like if today is a Tuesday, then what day would it be? Perhaps 24 days from today. All right. So to answer questions like that, we can use modular arithmetic and come up with the answer pretty fast, right? So let's say that the question is, if today is a Tuesday, then what day would it be 24 days from today? All right. So the way we would go about doing it is perform a modular operation. What is a modular operation? It involves a process of division. All right. So we have, if the question asked is what day would it be 24 days from today, then you take your 24 and you have to divide it by the length of your cycle. So here the length of the cycle is 7. So we are going to divide 24 by 7. So 3 times 7 is 21, and the remainder is a 3 as well. All right. So what does the quotient? So we have a quotient of 3, and in this case we also have a remainder of 3. What does the quotient and remainder tell us, and how can we use this to answer questions of clock arithmetic, so to speak? All right. Now, the quotient tells us how many cycles you would need to run to come back to the date or to the day that you started from. All right. So based on the 24, all right, based on the question which asked what day would it be 24 days from today, then you have to come around 3 times to land on a Tuesday again. All right. And that Tuesday, I'm going to mark the start day. I'm going to mark as day 0. All right. And then the remainder tells us how many days you have to go after you land on your start day. All right. So 3 tells us from Tuesday, you have to go 1, 2, 3 more days. So 24 days later, you would be on a Friday. All right. You would be on a Friday. That's 3. And this 3 is really the remainder. You know that by looking at the remainder from the modular operation. So we are going to use this process in order to work through this example. Now, another thing before I finish giving you the background of modular arithmetic, is that we number the days, all right? We start from 0. So this day we start from is indicated as 0. And then the other days would go like 1, 2, 3, 4, and then 5, 6, right? And these numbering actually comes from all the possible values that one could get from the remainder after the division, all right? So if we are dividing by 7, then the possible values of remainder would be from 0 to 1 less than 7, all right? So we'll mark the initial date that we start from. In this case, we said if we are on a Tuesday today, so we mark that as day 0, and then we numbered the days in increasing order. So 1, 2, 3, 4, 5, 6, right? So we are going to again use this process to solve the problem, the word problem given to us. So we'll keep this in the background, and with this understanding and with this information, let's see how we can apply it to solving the problem here, right? Now I'm going to first read and understand the question, and then I'm going to try to set it up so that you can visualize the information given as well as visualize the circle, because once you do that, once you have a picture of the cycle, it will be easier for you to do the counting and then answer the questions they're asking, all right? So the question is about the weekends off. So let's read through it. A manager of a retail store has both Saturday and Sunday off every 7 weeks. It is week 2 of the 7 weeks. So what it's essentially trying to say is that a person, a manager, has to work 7 weeks consecutively before he can get both Saturday and Sunday off. And he's presently in week 2 of that schedule. All right. So if I were to write this out, I'm going to just lay out the 7 weeks. So week 1, week 2, week 3, week 4, week 5, week 6, and finally week 7. And at the end of week 7, the weekend that comes at the end of week 7 is when he gets both days off. And after that, the cycle repeats. That means he has to start again working 7 weeks, week 1, week 2, week 3, all the way to week 7 for his next 2 days off, 2 days of the weekend off, right? And it also says that it is week 2 of the 7th week. So that is where he's positioned. He's already worked week 1, but currently he is in week 2. So I'm going to kind of box that week because that is going to be the starting point for us to answer the questions. And week 2, I'm going to just mark that as 0, position 0, so to speak. All right. And then the weeks that follow, it's going to be 1, 2, 3, 4, 5, and then 6. All right, so it's best to mark or indicate the week that you are currently in, if that is considered the start week from where we'll do the counting. Indicate that as 0, all right? Number that as 0, and then the other ones will go in increasing order of 1, all right? Now, the question says here, determine the number of weeks before he will have both Saturday and Sunday off. So what this question is asking is, given that he's currently in week 2, how many more weeks does he have to work to get to his weekend off? All right. So we are positioned in week 2. All we do at this point is, or to answer this question, is count the number of weeks until week 7. All right. Here we do not need to perform any modular operation. Just count the number of weeks to week 7. So 1, 2, 3, 4, 5. So the answer to this question will be 5 weeks before he will have both days off, both Saturday and Sunday off. That's all. All right. So here we just performed our counting from the week that we are in presently. Now the next part of the question says, will he have both Saturday and Sunday off 25 weeks from this week? All right. Now here there will be some modular operation that we will have to perform to answer this question, because they are talking about how many, if he will have to work both Saturday and Sunday, 25 weeks from this week. So 25 weeks means more than one cycle. What is the length of this cycle? And that's important to know to answer this particular question. So the length of the cycle for this question is 7, right? It's after every 7 weeks that the cycle repeats. So length of the cycle is 7. And the question says, after 25 weeks, will he get Saturday and Sunday off? All right. So what we do here is we take our 25, since we have to perform a modular operation, take 25, and you're going to divide that by the length of the cycle, 7, and when we perform the division, 7 threes are 21, and then we have a remainder of 4. So 3 is the quotient, all right, and 4 is the remainder. 4 is the remainder. Now, what does the quotient and remainder tell us? The quotient tells us that to get to 25 weeks, all right, we have to complete 3 cycles, all right? There are 3 complete cycles which will bring us to week 2. That means the position that we started from, right? And that will be 21st week, all right? So after 3 cycles, we will arrive at the initial position 0, all right, home base, and that will be 21 weeks. So this one is going to be 21 weeks. And then to get to 25 weeks, we have to count 4 more weeks. That's the remainder. All right, how many weeks do we have to count after the 21st week? 4 more weeks. All right, that information comes from the remainder. So week 3 will be the 22nd week, week 4 will be the 23rd week, week 5 will be the 24th, and week 6 will be the 25th week. All right, 4 more weeks from the 21st week. So does he get his weekend off after week 6? All right, week 25 is the same as week 6, correct? So does he get his weekend off after week 6? No, he has to go 1 more week, week 7. After week 7 is when he gets his weekends off. So the answer to this question, will he have both Saturday and Sunday off 25 weeks from this week? No, he won't have it. He still has 1 more week to work. So the simple answer here is no, he will not have both Saturday and Sunday off 25 weeks from this week, right? Now the last part of the question is asking what is the first week after 50 weeks from this week that he will have both Saturday and Sunday off. So this question is similar to the previous question, but this time it says what is the first week after 50 weeks. So we'll have to figure out how many cycles we have to complete to get closest to 50 weeks. And then from there, we have to do some counting to see which is the week where he will get both days off. All right. So again, we have to perform the modular operation, start with division. So 50, take 50. And what was the length of a cycle? 7, right? So you always divide by the length of your cycle. which is 7. So 7 times 7 is 49. All right, the remainder is 1. 7 is the quotient. It tells us the number of complete cycles, number of cycles to complete. All right, and 1 tells us, the remainder tells us how many more weeks we have to go after completing the 7 cycles to get to the 50th week. All right, essentially that's the message that this whole process is giving us. So after completing 7 weeks, we will get to the 49th week. All right, so if we go back to our picture here of the cycle, then the 49th week will be week 2. We will complete our cycle and return to home base, all right, which is week 2 in this case, and that will be week 49, all right, week 49. Let's make this distinct, week 49. So to get to the 50th week, we have to go 1 more week. So this will be, week 3 will be the 50th week. And the question is asking how many more weeks will, or at which week, like will it be the 50th week or the 51st or the 52nd or the 53rd? In which week after the 50th week will he get his weekend off? That's what the question is asking. So let's look at the weeks here. So if week 3 is 50th week or is congruent to the 50th week, then we have 51, 52, 53, and week 7, after which he gets his weekend off, is going to be the 54th week. And that is the answer. All right, essentially you counted after the 50th week to see where the 7th week is, the 7th week of the cycle is. So 51, 52, 53, 54. So the answer to this question is the first week, and that's the complete answer. And it's best to write it in a sentence. The first week after 50 weeks, from this week. Just use the wording in the question, from this week, that he will have both Saturday and Sunday off, will be the 54th week, All right, and that completes the answer and completes all the questions that they asked. All right.